Well, good morning, everybody, and welcome to the first of today's sessions, webinar sessions from Smart Vision. We're doing 3 webinars today, and we're going to start off talking about SPSS statistics and providing an introduction to that. It's a session that we run on a regular basis. And after that, we're going to look at data cleaning with SPSS, how to clean data. Typical issues that people have, and then later on in the afternoon we're going to look at regression modeling with SPSS. And you're welcome to join all of those if you haven't. If you're just joining this first session, that's fine. Just so that you're aware, these sessions are recorded, so you can listen to them again afterwards. You'll be able to get a copy of the slides that I'm using here. There aren't very many slides, and most of it's a demonstration, but we'll email out a link to you so you can download the materials. And if it's useful for colleagues who are unable to attend and you can get enough of them together, we may be able to arrange a rerun of the session. The best thing to do is just reach out and ask us, send us an email or something like that. Now, with regard to asking questions, all the lines are muted. We ask that you use the chat panel. If we run out of time, we'll follow up with you. I'll see if I have enough time to check for questions. We normally have a bit of time to check for questions near the end, so just be patient, and I'll see if I can address those as we're going through. We have quite a packed agenda to try and get through here because there's a lot of stuff we want to demonstrate to you. If you haven't joined any of these sessions before, you should be aware that we usually do an introduction to who we are. At the start, we are Smart Vision Europe. If you don't know who we are a accredited partner to IBM, as well as Predictive Solutions and Data Robot. And we specialize in statistics, machine learning, advanced analytics, data science, all that type of stuff. And we provide a lot of the SPSS technology in the UK to a huge range of different sectors and applications. That being said, we do work with open source technologies like R and Python and Spark and things like that. And we're a relatively small company. We're made up of a sort of veteran team of people who've worked in the analytics industry, and particularly with SPSS. For the past 30 years, I think I joined SPSS in 1995, so it's 29 years ago, as an instructor, teaching statistics and teaching how to use this package. And after that, I worked for SAS for a while and worked for IBM for a while as a consultant. And that basically means as a small organization, we've got very deep experience of applying this type of technology as well as, data science technology across many different applications in many different sectors, whether it be retail industry or telecoms or media or manufacturing or central government or housing and healthcare, etc. So talking about SPSS statistics and providing people with a grounding in it is something that we do on a regular basis. So our agenda today is we need to provide an overview of IBM SPSS statistics, just trying to get you kind of an overview of what it looks like and how you work with it. And then we're going to work through a sort of process of getting data into the system, formatting the data or fixing issues in the data, and then manipulating it so that we can, create filters or create new versions of fields, and then look at various options we have with regard to analyzing it, including using things like SPSS tables to create publication quality reports, or using chi-square tests to look for statistically significant differences in groups, that kind of stuff. Very standard sorts of things that people might do if they were analyzing data in SPSS. So first of all, an overview of IBM SPSS statistics, give you a bit of context of how this software comes about. It's one of the world's most popular data analysis and statistical analysis platforms. It's been around since 1968. At the time of acquisition by IBM, I think in about 2008, 2009, it was the world's oldest public software company. It's used for everything from epidemiology and healthcare to market research, survey research, business analytics, direct marketing, credit scoring, and fintech, process modeling, asset management, and predictive maintenance and things like that, and quality control. So rather like Excel, it doesn't really have a typical user. The initial, I suppose, typical users of spreadsheets like Excel and Notice 1, 2, 3 would have been accountants. But these days, they're used by everybody, of course. In the same sense, the SPSS statistics would have been used by people who were, statisticians or social researchers or psychologists, something like that. But these days, it's used by a vast range of different people for lots of different applications. Now, the sorts of analytical routines that one would get in a really basic copy, in the base copy of what we call the base copy of SPSS, are things like crosstabs and lots of tables and descriptive statistics, means, medians, that type of stuff. But also a host of different statistical tests, like classical tests like t-tests or analysis of variance or different types of correlation, as well as things like linear regression or identifying relationships and groups using things like principal component analysis, factor analysis, cluster analysis, segmentation techniques, if you like, and a lot of different graphical analyses and the ability to record your analysis through syntax or to run the system through code, if you like, and to export the data and the output in lots of different formats, as we shall see. So a lot of stuff in the base software. Now, that being said, you should be aware that it comes in different flavors. SPSS comes in different flavors, and that's because you can bolt on additional functionality in the form of what are called modules. These days, IBM tends to bundle them together. So you'll hear of SPSS Professional, which is a bundle of different modules been put together, like the regression module and decision trees and tables and things like that. Or you'll see the premium version, I think, which has everything in there, plus something called structural equation modeling from a tool called AMOS. So the idea is that if you were working in something like market research, you might not be that interested in advanced statistics, which tends to be used more in things like drug research and that type of stuff, clinical trials, where people are doing very complex sort of analyses of variance and general linear modeling. You might be more interested in things like decision trees, tabulation, maybe conjoint analysis. So you could purchase these individual modules, and they would just appear as additional menu items within SPSS statistics. It'd simply pop up, and they're unlocked with a code. You're basically given a code, and it just basically unlocks it. So it's not that difficult to have them installed. That being said, you should be aware that there are a lot of different modules there. If you go onto our website, you'll find that if you click on each one individually in the Smart Vision Europe website, you'll see a little video that we've produced. It's usually about 2 to 3 minutes long, which just gives you a quick overview of what they all do. And obviously, there's too many to go into it at this stage, as some of them are quite esoteric. But suffice to say, if you did have a module like the IBM SPSS decision trees, which I think is included in the SPSS professional bundle, then what that would appear as is simply an additional dialog box or a different menu item within SPSS. And decision trees is one of our favorite modules because it allows you to build predictive models. It allows you to create profiles of patients, of customers, of pupils, of students, of employees, of customers, of machines, if you like, or and whatever the unit of analysis is that you're working against. And it allows you to find key behavioral segments, and it's very popular because it represents models in a visual and easy to understand way. So here we have, for example, a decision tree being used to model survival on the Titanic. It finds the most important factors that discriminate between survival and non-survival, that being a key outcome, of course. And it says, okay, the most important factor is whether or not they're male or female. And for the males, the next most important factor is their age, and the next most important factor is the class that they're traveling in. And for the females, it says, okay, age isn't important, so it doesn't use it. Class is the second most important factor, and it even groups together second class and crew because their survival chances are not statistically different from one another. So it groups them together. So it does a lot of clever things. It allows you to build a profile like this. It identifies the subgroups where, people with the lowest level of survival happens to be adult males in second class, not in third class, interestingly. and where things like exceptions to the rule, where things like age is important for males, whether or not they're an adult or a child, but it's not important for females. And that of course, is really useful, whether you're looking at things like satisfaction, or you're looking at, patient outcomes, or whether you're looking at people who are going to respond to some sort of stimulus or an advert or something like that, or a marketing piece. So it has many, many different applications, and it, of course, is very visual. So that'd be a typical example of a module that one could add to SPSS statistics. We're not going to talk about that today. You should be aware, though, that we do webinars on SPSS statistics, and if you go onto our website, you'll see recordings of previous webinars that we've done. So if this is of interest to you, by all means, go onto our website and have a look at it, as well as any other of the web sessions that we run in the past. Okay, as I say, we have a little video guide, a short video guide to each of the SPSS modules. We're able to click on each of them. It just gives you a quick overview if you're ever curious to find out what exact tests is, or what's included, and what does missing values do, that type of stuff. It's probably the quickest way on the internet for you to figure out exactly what's in each of these different applications. Okay, that takes us to just before we begin our demonstration. When we talk to people about SPSS and we're teaching SPSS statistics to individuals, we're trying to impress upon them, what it takes in order to be something that's somebody who's quite competent with working with that type of application. And people might understandably think, well, in order to work with these types of applications, you got to be like a really good statistician or something like that. And that's not the case. In fact, there are three key areas, and this is pretty much true of anybody working with any type of analytical tool, whether it be a statistical tool or just a reporting tool. And the three key areas that we try to cover are, getting data into the system, because most people are out there collecting data using other systems, whether it be Excel or whether it be databases or forms that people use, Qualtrics, or the survey platforms, or systems like CRM systems or HR systems. Data's being inputted, and it's being stored somewhere, and it hasn't been stored or inputted in a way that has been set up necessarily to be analyzed in tools like Stata or SPSS, or even Excel, or any other tool that you can think of. So therefore, a key aspect of it is trying to get the data into the system and trying to format the data in a way that that system likes to work with. And SPSS has its own particular way of dealing with data, its own particular way of formatting it, and we need to address that. And the second thing you need to be good at is you need to have some sort of capability around transforming and manipulating the data. So that could be things like, well, I only want to work on a subset of data, so I need to define a filter. I need to clean the data in some way because there's lots of groups in there that I'm not interested in, or I want to group together. So I want to take age, for example, and turn it into age group or something like that. And then you have the analysis itself, all the different types of analyses one could do, whether it be visual analysis, tabulation analysis, statistical analysis, machine learning, and the deployment of the results of that, whether it be sending it out in PDF or PowerPoint, or sending the new data that you've created in the form of predictions or segments off to another platform for reporting or further analysis. So the point here is that simply being good at analysis isn't necessarily the best approach. Really, one wants to have some sort of ability in all of these areas. Not that that should be daunting to you, because these are just pragmatic problems that one has to address. But also the fact that, if you do an introduction course, when we do an introductory course in SPSS statistics all the time, these are the three areas that we're focusing on. So we're looking at making sure people are reasonably competent in each of these three areas, and that forms the basis of a introduction of a foundation understanding of how to use a platform like SPSS statistics. And with that, we can jump out and take a look at SPSS statistics. If we look at it here, we can see that it appears, if you've never seen it before, it looks a little bit like a spreadsheet. I would say that's the first mistake that people make. It's not a spreadsheet. Don't think of it like a spreadsheet at all. This is simply called a data editor. It's simply where the data appears, made up of rows and columns. and we have menu items across the top. In fact, it creates other windows as well, as we shall see. It has the data window and it has the output window, and they behave almost like different applications. And you also have what's called a syntax window if you wanted to run commands through code or something like that. So there's different windows open. You could have more than one data window open at any one time. I've kept it simple here and asked it risk to kind of keep one open, only one open, so it doesn't confuse people which file we're looking at. And you can see it starts off here saying, okay, I've got nothing in this data set. It's called untitled one, and it's just called dollar data set. So it doesn't really have anything to work with. So the first thing we have to do is to get some data into SPSS, and one way in which we do that is go to File, of course, as you would expect, it being a Windows system, and we could go Open Data, and we went Open Data here. It would take us to a default folder, whatever was the last folder we used, or if we went to the preferences, we could point it to the same folder each time. And you can see that the SPSS file type is called SAV, what's called a SAV file. That's its own native file type. That's how it likes to store data. We might not have that. We might have a different data set. We might have an Excel file to work with. So I could click open at this point, or alternatively, I could go File, Import Data, Excel. It does the same thing, really. And then that looks for Excel files. Here we see with an Excel workbook here. There's a data set here called Employee Workbook. And if I click on that, it starts a little sort of wizard for me and gives me a preview of what that file looks like in Excel. I mean, I could go back here and say, okay, what's it look like? Let's double click on it. This is what it looks like in Excel. So you can see the field names are at the top here. They might not be, of course, but you can see it's just raw data. There's no labels, there's nothing happening, there's no tables or anything like that. It's just raw data. So that's what we're trying to read in, trying to get that into SPSS. And that should be pretty straightforward because the field names at the top, it assumes the field names are at the top of the data, at the top of the sheet, the first sheet. It might not be, in which case we could give it the range, tell it where to read the data from. It tries to figure out what type of field it is, whether it's a number field or a category field, or sorry, a letter field. You might have letter codes in there, like zip codes. And it bases that on 95% of the values in the column. You could actually say, no, I want to base it on 100% of the values. You switch that off. It's going to ignore hidden rows and columns. And sometimes you get string, what we call character string, like people's names or addresses. And they will have hidden spaces. So you might have a word like, Chicago or something like that. It's spelled Chicago here and then Chicago here again, but the second occurrence, it's got a hidden space on the end of the word or at the start of the word. You can't see it, but it's there. So you can ask it to look for hidden spaces and remove them. We don't need to do that here, so we simply click OK at that point, and it reads in some raw data for us into SPSS, and this is what it looks like. This is raw data. You can see the gender field here is a bit squeezed together. It's because it's only got a width of 1, because it's only got one character in there. We could just make that a bit wider. And we could play with that. What other types of data could we read in? We could read in lots of other types of files. We could go to, you can see CSV, text data, other third-party file formats like Stata or SAS or something like that. But very commonly, people are reading data in from databases. So I might go to import data database and go to new query here. I've got an SQL database on my machine here. I could hit main. And that would find all of those tables in the SQL database, of which there are many. You see, I've got one table here, B2B IT products and B2B transaction history, and I could go down through this wizard here. It joins them together. Or alternatively, I've actually got a really simple database, which is just an Access database version of this Excel file. So I can say, okay, I want to look for an Access database. Weirdly enough, when I go browse here, it looks for Excel rather than Access. I don't know why, but if I change it to Access, MDB, there's employee data as an Access database. And click OK at that point. You can see it's only got one table in it. It's the employee table here. Hit next. I can go down through this wizard and define an expression and SQL to ask it to, not take all the data, maybe just take the last 6 months worth of data. Because often when you're analyzing database data, it's a really large file. In this case, it's quite a small file. We don't need to worry about that. So we go next. It tells me what the field name is going to be called. I could change some of these fields to numeric at this stage if I didn't want them as character string. I can set the maximum width for the character string variables. Hit next. It shows me what it looks like as SQL and a SQL code if I wanted to run that again, SQL code, or I can save it as SPSS code, which is called SPSS syntax, and hit finish at that point. It's just going to overwrite the existing file I've got open because I've set it so that it has only opens one file at a time. But there's two examples of how we would read raw data into SPSS, and it is raw data that we have here. It's not formatted data in SPSS. It's just raw numbers. And that can be something of an issue because one of the first things you have to do, as I said, the first things you want to do is import and format data. And the reason why we format data is because if I look at a field like this job cat and I decide I want to analyze it, I can simply right click on any one of these columns and say, give me descriptive statistics on it. And it gives me a little table here telling me that the field is called job cat and it's got 3 values, 1, 2, and 3 in it, but I don't know what those values represent. I don't know what 2 is, I don't know what 3 is. And that's because that field hasn't been formatted. Now you can see it, and it did that, it opened up a second window. So the second window is called the output window, or the viewer window, sometimes called the viewer window. And we can jump back and forth between the data and the viewer window. In fact, every time I do any sort of analysis or anytime it produces any sort of result, it's going to jump to the viewer window, the output window, and show me a message or show me a table. So the first thing I want to do is I want to think about formatting these data that we have here. How many rows of data do we have? We have 474. We don't have a huge number of fields, but this data set is quite a famous data set. It refers to employees within a bank in Chicago in 1986 or something like that, around about that time. And the data was used in a court case for an equal opportunities court case where the bank was being sued by some of the employees for an equal opportunities issue, I guess, around pay or something like that. So you can see here that the variable, or as we call them, variables in statistical applications, not fields, but this field or variable gender here just has codes M and F. If I wanted to format that, one way in which I might want to do that is I double click on the header, and that jumps me from the data view to the variable view. Here's the variable view. You can see me jumping back and forth. Here's the variable view. The variable view is showing me the field name and all the properties associated with that field name. It says it's a string field. It's got a width for one character in there at a time, so I couldn't put AA or XX. It only puts one character. And I can give it what's called a variable label, which would, in this case, would be called sex of employee, because that's what it was labeled originally. And I can attach what are called value labels to that. Value labels indicate what the codes represent. So I'm going to say, well, code of F represents female, and the code of M represents male. Something that you'd bear in mind is that these are case sensitive. So capital F won't work and capital M won't work. These are lowercase. If I click here, you can see that suddenly these are labeled as male and female. That is cosmetic in nature. And I can display the labels, or I can display the underlying values. The values and the value labels are not the same thing. The values are simply the raw data. The value labels is how they're represented in analysis. So if I right click on this field here and do descriptive statistics, you can see now it gives me a little table saying sex of employee, female and male. And I could do the same thing here for job cat. I could go here and go, this is obviously job category. And I could attach value labels here. One is, I happen to know, is clerical. 2 is custodial. And 3 is manager. Okay. So these are properties that we're attaching. Now look at this. So beforehand we had just 1, 2, and 3. Now it says job category instead of just job cat. clerical custodial manager. Here I am formatting the data. Okay. And you might even have situations where you have missing values. For example, you might have a value in here of, I don't know, 9 or something like that. So this doesn't have a label. And when I do an analysis, it sticks out. Look, it's one occurrence of 9. Well, that might be because it's a special property, should be associated with it. And I should say 9 indicates that the data is missing. It's unknown. So that when we do descriptive statistics now, it goes into the missing category and it doesn't mess up our percentages. So our percentages are based on known values. And in fact, we can even give the character 9 or the value 9 its own value label, which is just say unknown. It could be unknown or unknown at this time or something like that. Run the analysis again. You see I'm running the analysis again and again. It's just adding more output each time I'm doing it. So it just constantly adds it to it. And look, you obviously don't want to watch me sitting here formatting this entire data set. So it turns out there's a trick. If you format it once, if you spend a bit of time formatting it once, you can save away that file and then use it as a sort of template in the future. Again, you can use it again. So I could go here to, I'm going to change this back to category 3 for manager, but I could go here to data and go copy data properties. And I could look for a file where I've already formatted the file. And it turns out I have done this in the past. Employee just the variables is what it's called. And that will automatically match by the column header, by the variable name, and copy all of the properties across from a external file to this file, just like a template. And in doing so, it immediately, as you can see, it immediately formats the data for me. So everything's formatted correctly. This has got dollar signs. These have all got this. Look, this is minority classification. If I look down the variable view here, we can see everything's got a label. We can see lots of them have got value labels. Not all of them require value labels, of course. Age doesn't. Funny enough, I could put age of employee. I mean, age doesn't require value labels because, obviously if I ask it to analyze age here, it says, okay, well, the range is 42. That means the minimum was 23 and the maximum was 65 and the mean was 37. The difference between the minimum and maximum is the range, which is 42 years. It doesn't need value labels. It doesn't need a value label for the value 47. It's just a number. Whereas we do need a value for a value label for something like 0 or 1, if that indicates yes or no, or if that indicates minority, non-minority. So it takes account of these, and in fact, you'll notice that even the symbols across the top reflect the type of field it is. So, for example, if it's a category field like this, or this one, it gives me percentages. Whereas if it's a continuous field like this, like salary, it doesn't give me percentages. It gives me summary statistics. So formatting the data is important because, of course, it means that we've set the data up in a way that makes sense to SPSS and reflects the nature of the fields that we're working with. It reflects the nature of the values that we're working with. For example, if we have any missing values in there, we need to tell it that -9 or 99 or 0 is missing and indicates that that data is non-legitimate and shouldn't be used in it. Okay, so you see me doing some really basic analyses here where I've just been right-clicking on this and saying, give me some descriptive statistics. This is a really good way. You can see here, for example, it says minimum -1 and maximum 21. That's a really good way to spot, any problems of the data there. So education level in years has got a minimum -1. That doesn't make any sense, obviously. Somebody can't have -1 years of education. So I could go here and say, look, there's a missing value for 0, but there should also be a missing value for -1. And the reason why you might have more than one missing value is very often because they're missing for different reasons. So you often get 3 codes in survey data, for example, one for 99, meaning refused, 98 for not applicable, and 97 for don't know. So you might have something like education level, don't know, or encoded as -1, and 0 for not available yet, or refused or something like that. So now if I do the analysis again, having identified -1 as a missing value, you can see the minimum goes from 8 years to 21 years, And it makes it probably has a tiny effect. There's a tiny effect here on the mean, because we've taken out the -1. You can see here it was 13.46. Now it's 13.49. So it's me doing really basic analyses. Other types of basic analyses I might do is I might go and do some descriptive statistics, and ask for frequency tables, and I'll ask for frequency table of employment category, and let's say gender, and ask for some basic charts. Let's say I'll have a couple of bar charts or something like that in there. Click OK. And it just goes and squirts out a couple of little frequency tables for me, showing me the percent, valid percent, and employment category shown as a couple of bar charts. These are really basic sort of simple analyses. If I want to get rid of my output, I just delete it at that point and say, okay, I'm going to start from scratch. Well, if I want to look at the relationship between fields, well, I might say, okay, I'm interested in the relationship between let's say gender and job category. Well, a classic way to do that would be because they're both category fields, would be to say, okay, well, I want to do a crosstab. So I'd go to descriptive statistics and go down to crosstabs, and let's say, okay, let's look at gender, and I'll put employment category across the top here. Really useful in SPSS is you have these resizable dialog boxes, and you can, if they have value labels, you can right click on the field and say variable information. You can see the codes. See, it says F for female, M for male. Same here. Very useful. I can see the codes 1, 2, 3 for manager and that sort of stuff. So it's giving me information about where the variables come from. If I just ran that, it would just give me a really basic crosstab where one field is cross-tabulated against the other. You can see there are 0 custodial female employees, only 10 female managers, and 75 male managers. But there's more males than there are females. 258 males and 216 females, and quite big differences in the group sizes of clerical custodial manager. So normally what one would want to do is one would want to add percentages at this stage so you could compare the groups more effectively. And I could rerun the analysis at this stage. One way to get quickly back to that dialog box is to click on this button that keeps a record for the last 12 procedures you ran. If I click on that, it just pulls up crosstabs again. And there you can see it. We're not starting again from scratch. It remembers the last procedure that we ran because it does tend to be iterative as we're running these analyses. And if I click on cells, that's where the data values appear. I could say, give me row percentages. Click continue and OK. And it adds another crosstab at the bottom here. You can see this is called a case processing summary. It's just telling you can hide these pieces of output just by double clicking on them. It's just telling you how many cases it processed, how many missing values there are. But there's no missing values here. There's 474 cases. 100% are valid cases. 0 are missing. So here we can see 95% of the female workers were clerical. Only 60% of the male workers were clerical. 4.6% are female workers or managers. 29% of the male workers are managers. And if you wanted to test to see if that was, to use the dreaded term, statistically significant, not a term I'm very happy about, but it is a term that's used widely. You can ask for what's called a chi-square test. And it's a test of significance. You can go to statistics here, ask for chi-square. Note that there are many tests, even associated with something as simple as a crosstab, many different types of tests. That's typical of SPSS. Click continue at that point. You could even ask it to add a clustered bar chart at this point. Click OK. And it does the same procedure again, but this time it's added a little statistical test. And if I double click on the output here, I can actually right click and say, what's this? What's this mean? And it says the significance level based on the asymptotic, that means estimated distribution of a test statistic. Typically, a value of less than 0.05 is considered significant. So if we were testing a null hypothesis that gender is completely independent of one's employment category, in no way are they related, we would be rejecting that null hypothesis because this value, of course, is less than 0.05. In fact, it's less than 0.01. In fact, it's less than 0.001. So it's actually showing that in its asymptotic significance. And here's our little bar chart that goes with that. Speaking of which, by the way, you could actually double click on these charts and you can edit them. So you can actually go in here and say, okay, well, I'd like to change this, and I'll change it in such a way. So instead of a clustered bar chart, I'll have it as a stacked bar chart. Apply like that. And then I could say, okay, I'll have it stacked to 100%. Well, you can see that, pretty much almost all the female workers are clerical nature. None of them are custodial, and there's only a few managers there. So it's hardly surprising it's statistically significant. You could go back to this, of course, and you could say, and now I want to test it by minority classification, just swap them around, or do them both at the same time if you wanted, or even split minority classification by whether or not they're male or female. So you get two crosstabs. This is a third. So it's very functionally rich is the crosstabs procedure. It looks like it's very simple to begin with, but there's actually a lot you can do in here. Let's test minority against employment category. And again, statistically significant, 74.4% of those in a non-ethnic minority or clerical workers composed compared to 83% of those in an ethnic minority group. 21% of those non-ethnic minority bank employees were managers, compared to only 3.8% of those in a minority group who were managers. And again, statistically significant, we reject the null hypothesis that that minority classification is completely independent of one's employment category. Okay. What happens if we wanted to compare salary by job category? Well, we could compare the averages. We could do something like, let's look at job category, and I could do a comparison of means here and say, okay, let's look at current salary and beginning salary, and let's say education level. I could throw them all in. I could go to options here, and I could throw in like median as well if I wanted. And you can see there's a lot of different statistics here, the minimum and the maximum, that type of stuff, the range, the variance. Lots of different stats. I can move them around here and say, okay, I'll have number of cases on the end, standard deviation. Click OK. I've got a statistical test there I can run. You can see it's producing an output here. I can actually double click and interact these outputs because there's so many elements in this output. We have, 3 different variables here. We have 1 variable here of 3 different categories, and we have 4 different statistics. A lot of information in that table. Hard to compare one against the other. You could call up what are called pivoting trays here. And you could say, okay, look, I just want to nest the statistics. I just want to look at the means first of all, and then drill down into the medians, and then drill down and look at the standard deviations, and then look at the number of cases at the end here. If you're getting overwhelmed with that, or alternatively, you could say, okay, I'm going to put the statistics across the top. Does that help? Does it make it worse? Up to you. I could put the variables down here. You can swap around the dimensions. You could say, okay, look at that. Does that make it easier? Is that an easier way to play around with it? So pivoting and interacting with the output is quite important. Bear in mind, of course, that you could actually interact with the output itself and create charts. So you could, for example, here say, I think I can just do it. I guess I would just go mean. I'm using control click here and then go right, create a graph of that. It would create me a little bar chart of those 3 different values. So you can't chart the data directly from the output. Again, another little interesting and useful feature. But what I couldn't do, of course, is I can't compare these in crosstabs, and you can't do a crosstab of employment category against salary, because that's just going to look mad. That's just going to look like this, because salary isn't categories. It's not a categorical variable. It's a continuous field. Makes no sense. So to deal with that, one might want to say, okay, I want to take salary and turn it into a banded group. So one could say, okay, how would I do that? Well, if I go to transform and click on visual binning, I can band this by saying I want to look at current salary, hit continue, and it scans the data, and it shows me the shape of the salary distribution as a histogram. And I can say I want to create a new field called sal band or sal grouped. And it's already going to create a label for me called current salary binned. Binned just means grouped or banded. So I'm going to change that to grouped. And then rather like slicing a cake, I need to decide, where the cut points should be. So I could say make cut points. And I could say, well, look, I want you to slice it more or less equally. And I want you to put 3 slices in there so I get 4, or 3 cut points in there so I get 4 slices. And when it does that, it shows me where it's going to slice it. I can see actually some minus values in here, so I should probably deal with that and make sure that they are they're taken out later on. I could get rid of any minus values and rerun this procedure. But suffice to say, they're in there and they're missing values. They're being seen as legitimate values. In fact, I can't live with it. I'm going to have to get rid of it now. Let's have a look at this. So if I go to salary, just right click on it. Yeah, you can see the minimum is -1. So there's an there's an unidentified missing value in there. There you go. Let's put it in. Let's do it now. -1. Can't live with it. Do it again. Right click on it. Right, now it goes from 15,000 to 135,000. We've got rid of any -1s are in there. So we go back to transform, visual binning very quickly. You can do this quite quickly once you get used to it. And it scans the data. We call it sal band. The new variable is called current salary grouped. That's the label for it. We're going to make cut points and we ask it to slice it into 4 using 3 cut points. It shows me where it's going to slice it at 24,000. The next slice point is weird. It's kind of 28,650. Well, I could actually move that around. So you can see how I interact with this and it will update it. It's quite useful. Or I could double click in here and just change the value. I'll just change it to 29,000. And here we have 37,500. Well, in the same sense, I could change that to, let's change it to 38,000. On the basis that we're not that bothered that it's exactly 25% in each group. There's 38,000. And then we could ask it to make labels for these new groups it's creating, because otherwise it'll just call them 1, 2, and 3, group 1, 2, and 3. And we can we can change the labels. So we can say up to $24,000. Let's change that. So it's and this one here says 38,001 plus. Well, that doesn't really make sense, does it? So most people wouldn't express it that way. You can say over 38,000. That makes more sense. Reads more easily. And then we click OK at that point. It says I'm going to create a new field for you. It creates a new field. Here's a new field that's created. It's added onto the end where you can right click and check it. There it is. It's roughly 25% in each group. And if we went back and did crosstabs again now, we could look at, instead of current salary across the top, we could say current salary grouped across the top. Click OK at that point. And now we can say, you know, what percentage of those on up to 124,000 are clerical workers? Well, 100% of them are. What percentage of those on 24,000 to 29,000 clerical workers? Well, 98% are. Or alternatively, we can rerun it again if you don't like that way and you want to swap them around. You can say, okay, let's run it like that. Say, oh, what percentage of clerical workers are on up to 24,000? 33%. What percentage clerical workers on 24,000, 29,000? How many on over 38,000? Only 8%. Managers, 97% are on over 38,000. What percentage of custodial workers are over 38,000? None. And in fact, it was the clerical workers, I believe, that took the court case, took the bank to court. This is, of course, statistically significant, as we might expect. What happens if we wanted to remove managers from that group, let's say, or take out the custodial group, because it was really about custodial versus managers? Well, if you wanted to filter data, you could go to select cases here, data select cases. Let's filter and go if condition is satisfied. And I'd say I want to get rid of the people in the custodial group here. So I need to know what the code is for that. The code is code 2, group 2. So that would be just defining an expression, which is jobcat is not equal to. That's what that means, not equal to. I think you can use NE, capital NE, not equal to. 2. And then with regard to what happens to the data, well, it can either be temporarily filtered out in the active data set. So it'll just be temporarily filtered out. And you'll see little diagonal strokes appear for all of the custodial workers, meaning that they won't be included in any subsequent analysis until you switch the filter off. Or alternatively, you can create a separate data set. So I could say, yeah, create another data set here, and I'll call that data set no custodials, something like that. Click OK. And it goes off and it creates this little data set. You can see now I've got 2 data sets open. One's called Untitled 3, and the other one's called Untitled 4, no custodials. They don't have a name for these data sets because we haven't saved them yet. We haven't given them a name, but there's no custodials, and we know that's no custodials because we go to jobcat here and we do descriptive statistics on it and see the output. There's clerical workers, there's manager workers, but there's no custodials. They've been filtered out, and now we have a group of cases where that group has been taken out from that data set. If you want to go back to the original the data set, you could just close this down and say, I don't want that group. I just want to go back to the original data set. That's one way in which you might want to filter data. Another way in which you can filter data or really play around with the tabulation, if you like, is to do things like use a module like the tables module, the custom tables module. If I click on this, custom tables module allows me to mix procedures like crosstabs and means and things like that, the little procedures I've touched on thus far, and to create much more complex tables. So I could, for example, here pick up the employment category. The custom tables allows me to use this dialog box, which is very visual. You can see it's showing me the categories along the bottom here. One of the most, probably the most popular module that people work with, particularly in market research. Here's minority classification added on the end. What happens if we want to put gender in there? Well, I could put gender across the top here. I could make a cross tab. I could put gender across the top of this. This is called stacking. Or I could make gender a subset of employment category. So now we have clerical, female, male. And I've got a lot of control. So I can say, okay, look, don't show me the value label, gender of employee, because it's pretty obvious what male and female refers to. And for minority classification, I'll put that across the top now. You can see it's going to show me counts. And I can say, okay, look, I've got some continuous variables here. So I want to look at people's current salary. I want to look at their age. And I want to look at their education level in years. For some reason, I want to look at current salary, and I don't want a mean for that. I actually want that to be a median, because for whatever reason, let's say that's how we report salary statistics, and just say apply to selection or apply to all. So these are means, these are medians. So you got a lot of local control here. I go to employment category here and say, okay, let's go to categories and totals. And I can say, actually, I don't want the custodial group, so I'm filtering them out there. And I'll have a total here. I'll have the total at the top. Hit apply at that point. So I'm really playing around with it. I'm putting total at the top up here. You know, I'm going to change. Sometimes people use the term base instead of total. And I'll have this, instead of counts, I'll have it as percentages. So I'll have it like row percentage or something like that added in there. Let's see if we can have that row percent and just change that. Apply the selection, click OK. Okay, so now we get a more complex table. I could change the formatting on this. I can look at the output itself and move things around. I can interact with the output and say, actually, I'd rather have that over there. I can go to format. I can create my own table looks and my own templates. In fact, we have a bunch of table looks that you can download off our website. Ones that we've created, but these are ones that ship with SPSS. We could, could look at different table looks. You can see these. Some of them pretty ugly, I think, but I create my own ones. But you get stuff like the one I use is Web Report Blue. I prefer that rather than the default one. But there's other types of ones here. You can have Cobalt, etc. I could click on that and say, okay, I'll have it in that format if you prefer. And you can have that set up by default to be your table look, or you can apply them on a local basis. So that's using the custom tables module, where we're kind of got a lot more control over our output. One of the things I wanted to touch on at the end here was just let's touch upon the graphics themselves. So we go to the graphics, go to chart builder. Perhaps I'm much more interested in charts rather than tables. Well, the chart builder offers you a menu of different charts that one could work with. So I like to work with things like scatter plots because I do a lot of analysis and regression and things like that. If I wanted to look at things like the relationship between current salary and beginning salary, you can see I'm just building up the chart by adding these fields as elements. And I could say, okay, the color is actually going to be dictated by their current salary. So I can put that in again. I can put that. Oh, maybe I can't put that. No, the size can be. Oh, yeah. So the size can be the current salary, and I'll say I'll have it colored by their employment category. So I can say, okay, different colors for employment categories. Click OK at that point. Oh, it's giving me a warning. What's it like? What's it says? It doesn't like it. Transition field can't invoke its syntax. Let's try it again. Let me just try it without that. Let me just try a really basic one. See if it likes that. Okay, so it's happy with that. Ah, we've still got some minus numbers here in beginning salary. I should have done that. Beginning salary. Let's just make sure if I right click on this and do descriptive statistics. We've got some minus ones in there, so I didn't delist those guys. Let's go to missing. Get rid of them. Make sure that they're declared as minus ones. See why this is important, of course, because you do the charts now. And you can see there's a difference. This one is going down to minus 20,000. Now it's going down to 0. Let's just try this again, chart builder. Something, and there's some element in there. Let's see if I do employment categories, put color in there and click OK. Does it like that? Yes, it's happy with that. Okay, so that'll do for now. So we've got clerical custodial managers. You can see where the custodial workers are, where the clerical workers are, and where the managers are. You should be able to add an extra element to it. You can add, it's getting a bit complicated now, because you could make something like the size is based on, whether or not they're the age of the employee. So the older ones we can see at the bottom ones. So now we've got like 4 variables in this chart here. We've got, beginning salary against current salary. We can see that the higher your beginning salary, the higher your current salary. We can see where the oldest employees are. They tend to be down among some of the most poorly paid ones. They tend to be clerical workers. Some of the younger employees are kind of these managers in the sort of middle management group, and people around about this salary. So an interesting way to see it. If I wanted to do a different type of chart, I could hit reset here and say, okay, now I want to look at, let's do a bar chart again. Let's do a stacked bar chart from scratch. I could say, okay, let's look at employment category, and I'll have that colored by current salary. I could change the statistics here to say, okay, I'll have the percentage based on not the grand total, but for each x-axis category. And you can do clever stuff. Like if you run that, it's just going to give you that type of standard color palette here. But if you go back to it, you can go to the chart appearance and say, okay, I've got different color palettes that I can choose. There's one there, bright, legacy. That's an old type. Pastels, that type of stuff. You prefer that. Alternatively, you can create your own color palettes. I think I've got one hidden away in there. If I browse one, let's see if I can find it. So, user specified browse. Let me just see. I've got one from another webinar that I've used. I think it's in housing or something like that. Let me see. Tenant satisfaction might be in there. Chart templates. There you go. So I've got. You can see. Again, we provide a bunch of chart templates that you can download. So I've got one here. So called Lollipop. It's just basically, as you guess, it creates. It creates different colors that are kind of banded according to the salary, where the highest salary is the green group here over 38,000, where the lowest salary is this dark red group up to 24,000. So we can do that. And we could even go back to that and say, okay, that's great, but I'd like to add some, I'd like to have it split by gender. So I could put gender across the top here. It's a panel. Click OK at that point, and it would create 2 charts for you, one for males and one for females, if you so wish. The last thing I wanted to point out here is really the fact that you can create your output, and you can export your output. You can go to File here, and you can go to Export, and you can see there's a lot of different options here. If you're going to be doing a lot of analysis downstream in Excel, something like that, it exports quite well out in Excel. A good tip is to use all visible rather than all, because there's a lot of hidden information in here. So system information and stuff like that about which file it came from. In fact, if you look at any piece of output in SPSS, like that piece of output there, and then double click on where it says notes, it actually opens up the system information. Above that, it tells you what procedure was run. It tells you whether or not there was a filter in place. It tells you when it was run, how many rows of data, and lots of information about what type of file was used, etc., etc. So you don't really normally want that stuff exported, but you could go to File here and say, okay, I'm going to clean this up, get rid of all the output I don't want to include in my report, and say export everything as visible as XLS or as Word or as PDF if you so wanted. I find that if I just click on my PowerPoint here, I'm just going to shut them apart, close out of my PowerPoint here, and just go to File, New. Let's go for a blank presentation here. Get rid of this. I find that pasting stuff as what are called Microsoft graphics objects works very well if Microsoft supports that type of chart. So let's say if I pick this chart here and I right-clicked on it and said copy as, you can see it says Microsoft graphics object. If I copy that as a Microsoft graphics object and then put that into, if you're working in Microsoft, into Microsoft tool, if you go here, look at this, you can see it says destination theme. You can see it immediately picks it up as a Microsoft object, and I can go to chart design here and I can choose a different chart design or a different layout if I so wished, because it's actually pasting the information behind that. So you don't have to stick with the SPSS format and paste them instead as images, which are just photographs of it, but rather paste them as Microsoft graphics objects. So if it supports it, you can paste most objects or export most output as objects which Excel or PowerPoint or Word or anything in Microsoft Office will support. And the last thing I really did want to point out was the fact that every time I do an analysis in SPSS, like a crosstab or something like that, if I hit the button marked paste rather than the button marked OK, it shows me syntax. It actually shows me syntax, and it's recording my analysis. So I can run SPSS in code format. And it means that I can record all my analyses from start to from scratch. And if I had, for example, some syntax job, I could rerun my analysis on a regular basis. Let's just see if I've got one here for this one. So we've got getting started with SPSS statistics is sample syntax. So you can see I'm actually going to start with a completely blank data set here where we start with nothing. And run that syntax. Let's see if I can get to it. Let's see if there's my sample syntax. Let's shut down all the other stuff in the background. Don't want the output. I'll get rid of that. I'll just run the syntax. Here's some syntax I created earlier where I've pretty much reproduced everything I've done thus far. And I hit run on that. It just goes and grabs some data. It formats the data, attaches output to it, and it squirts out a bunch of different bits of output and reports for me. So you can record your analysis if you so wish. Listen. Can you flip it around so the highest salaries appear at the top of the columns and not at the bottom? If you mean in the legend, yeah, you can do that. Yeah, you can do. You should be able to do that. So it's just the way in which it's been coded, whether it's 1, 2, 3, 4, or whether or not whatever the colors are that you've used. So yeah, so it's just the nature of the code of the way in which it's been coded. Let's see. If we were turning to the slides here, just to close this off, you should be aware that we have a bunch of additional resources that we can work with. So we have some FAQs where you can find out everything about, for example, what you've got installed in your copy of SPSS. This is URL. It will link you to that part of our site. How to merge files, typical things, how to change the language. A bunch of video guides on, many topics on how to do recoding, that sort of stuff, many demos of that. Lots of information in the SPSS software, blog series. And we have our own YouTube channel, so there's tons of stuff on syntax, on charts, on reporting, on significance testing, just hours and hours of material that we have recorded there for you to make use of. I should also point out that people who are customers of Smart Vision and who are using SPSS and you've acquired it through Smart Vision, you get access to our library of training materials, which are free to Smart Vision customers or available to purchase from non-Smart Vision customers. Working with us, you should be aware that we have a range of different consultancy services where we can provide 1 to 2 days support for some simple mini projects or a much deeper application-based projects that require a more involved consultancy engagement. And you should be aware that you can source your software directly from us. We can assist with pilot selection. We offer, as I say, training consultancy services, as well as even identification and recruitment of analytical skills in the organization. Generally speaking, we offer no strings attached technical and business advice relating to all things analytical, but we are a formal support partner to IBM in the SPSS statistics product group. So we offer ticketed support, and obviously we're a smaller organization. We're experts in this software. We're pretty good at being able to turn around queries quite quickly. In the meantime, I hope you find that useful. Stay tuned if you want to see some of the other webinar sessions that we're going to be running today, but also be aware that we have a bunch of recorded sessions from previous engagements, which you may want to check out again on our website. Thanks very much, and we look forward to you logging in again in the near future. Thank you.